The number e is a number that occurs in nature and is a frequent base for exponential and logarithmic expressions. It's defined by the limit as n approaches infinity of 1 plus 1 over n all to the n power, which when you end up plugging that in and seeing what happens, so remember what limit notation means is that we're looking at this function as your n value gets extremely large and what that function is approaching. So if you start to look in your calculator and you actually put this function in your calculator, and you look at values of n, you can look at the table and see what happens as your n values get larger and larger and larger. You'll see that this ends up approaching approximately 2.72. So remember we learned about that number pi back in previous math classes, where pi is an irrational number and it's approximately 3.14. So e is an actual special number as well, and that number is approximately 2.72. Now we can see the graph of e to the x, and it looks a lot like the graphs of the functions that are given by y equals 2 to the x and y equals 3 to the x. You can see y equals 3 to the x in pink, light blue is 2 to the x, and you can see that e falls right in between them, a little bit closer to the 3 to the x, which makes sense because y equals e to the x is about y equals 2.72 to the x power. So that makes sense that that graph is right in between those two. Let's solve some equations that involve e. So remember what we learned about earlier is that if we can write things where they're both the same bases on either side of the equation, of the equal sign, then we can just set the exponents equal to each other and solve. So looking at this problem, you can see that I have e on both sides of the equation. E is written as the base. So now we can just set the exponents equal to each other, and we get 3x equals 2 minus x. Get all of the x values on the same side, and we get that x equals 1/2. In 1990, the population of Oregon was 2.84 million people. In 2010, the population of Oregon was 3.83 million people. Let P of t be the population of Oregon in millions, where t is the number of years after 2000. This can be modeled by the formula P of t equals 3.298 e to the 0.015 t power. According to this model, what will the population be in 2020? So we're solving for P in the year 2020. Now T was the number of years after 2000, so that means our T value for 2020 is 20. When I plug 20 in for T, we get 3.298 e to the 0.015 times 20. And when I enter that into my calculator, I get 4.45 approximately. So that means in 2020, the population of Oregon will be approximately 4.45 million people. Letter B states, according to this model, when will the population reach 4 million people? Use technology to solve this. We can do this on Desmos by first plugging in what the formula is. So our original formula is P of t equals 3.298 times e to the 0.015 t power. Okay, Now we want to see when this population is going to reach 4 million people. So that's when P of t equals 4. So what I'm going to do is I'm going to actually just type in y equals 4 and see when these two lines intersect. I'll have to end up scrolling around here. I'm going to zoom out so we can see all of our function. So this red line stands for the formula for the population, and the green line is y equals 4. We can see those intersect right at this point here at 12.865. So that means that about 13 years after the year 2000, the population will be 4 million. So 13 years after the year 2000 is 2013. Now let's look at how to find the formula for an exponential function. Find an algebraic rule or formula for an exponential function f that passes through the points -1, 8 and 2, 1. We know that an exponential function is going to have this form, y equals c a to the x. We're going to do this just similar to how we found formula for equation of a line, which was y equals mx plus b, where you'd first need to figure out what m is and then figure out what b is, and now you have your formula. In this case, we need to figure out what c is and what a is. So what I usually do, there's two different ways to do this. I'm going to show you the way that I prefer, but feel free to go ahead and look in your book, or I actually have a link at the end of this slide that covers more videos on how to solve or how to find the equation of an exponential function given 2 points that will show the alternative method as well. So feel free to pick whatever method makes the most sense to you and is the easiest for you to do. What I usually do is I plug in these 2 points. So plugging in -1, 8 will give me your y value is 8, your x value is -1. So we get 8 equals ca to the -1. And then I'll also substitute in the second one, which is this point. So our x is 2, our y is 1. So that gives me 1 equals ca squared. Okay, so when I go to solve this, what I'll get is, what I usually do is I solve by substitution. So looking at each of these formulas, I have 2 variables in them. So there's no way that I can figure out exactly what c is or what a is based on just one equation. So what I need to do is get one of these in terms of only one variable. So this is when we go back to our Math 65 days and you solve for a variable, substitute that into the other one, and then solve, and then go back and back substitute. So for example, I'm going to solve this equation for c and get c in terms of a. So remember that anything to the 1 power is this, or negative power is the same thing as 1 over that. So 1 over a to the first is just 1 over a. So now to get the c by itself, I'm going to multiply a by onto both sides. So I get 8a equals c. So now what I have is I have c written in terms of a, and I can plug that in to this c here. When I substitute that in here for c, now I have an equation that's in terms of only one variable. So that gives me 1 equals 8 times a cubed. Get the a by itself by dividing by 8. 1/8 equals a cubed. To get the a by itself, we'll cube root both sides. And I get that 1/2 equals a. Once you have what a is, then we can back substitute that in to our formula that we had for c. So we know that c equals 8 times a. Well, now I know what a is, so I can get that 4 equals c. So I have my c value and my a value, which is all I need to be able to come up with this equation, which is y equals c times a to the x power. Now, we do have in the supplement packet for Math 111, which I have a link for that in our welcome module. It's also found here. We do have 4 different practice problems over this because your book doesn't cover this that much, and we want to make sure you get practice with this. This is necessary for some future classes. So please go here and complete number 1 on page 7 of the supplement packet, and please know that there will be a question just like this on the exam, so it is important that you know this. So if you do need some more practice, you can go over to this website and get some more video practice over this concept.